Hi, everybody. I'm Joel Simmons for another 2-minute Turf Talk. As many of you may know, we here at Earthworks run about 15,000 soil tests for clients from all over the country. Working with our friends at Logan Labs, we're able to get data that we can compare month to month. And oftentimes we see soils that are just really very difficult to figure out. And this is one I wanted to highlight. I have water, a water-soluble paste extract, and of course the standard soil test. But let's start with the water because that's where we should start when looking at a soil profile. And you can see by this water report here that we have virtually nothing in the water. It is as clean as can be. The cation-anion ratio is 1 or above, so it's not stripping. It might actually be depositing minerals into the soil profile. And the biggest mineral on this water is calcium. So calcium potentially may be being loaded on the colloid, but bicarbonates and sodium aren't high on this particular test. But as we start going through the rest of the profile, let's look at the standard soil test. And you can see on this standard soil test that the holding capacity is very low, the CEC is very low, and the organic matter is very low. So there's very little buffering capacity. And on these low CEC soils, we don't work very often with a base saturation model, but we will use this test to give us a guideline as to what's there. And as you know, base saturation doesn't work as well on low CEC as it does on a higher CEC soil. But you can see a lot of deficiencies. We would consider this phosphorus level low. Calcium, magnesium, potassium is low. But interestingly enough, sodium is building up on this. So we want to look at that when we flip over to the paste extract. Trace elements are not strong, and they're going to need to be provided to this profile, this plant material, through the spray tank. But let's look at the paste extract. Now this tells me of what's on the colloid, how much theoretically is actually being mobilized into the plant. And as you can see, there's very little nutrient here. There is some bicarbonate building up, interestingly enough, even though it's not strong on the water. But you can see cations are not very strong. So we're going to want to provide those minerals to that soil solution so the plant has a better chance at taking them up. You also want to notice here that the potassium level is lower than the sodium level, and this is going to set up for sodium-induced wilt stress and a lot of stress on the plant. So this is a situation where potassium is needed, and sodium flushing can be a benefit just solely for the purposes of preventing sodium flushing into the plant and dehydrating it and causing all sorts of wilt and stress problems.